This is May-June 2022, variant 21. So on to this next question. We have compound V is a liquid and it contains this particular amount of carbon, hydrogen and oxygen, and it has a relative molecular mass of 280. So the question asks for molecular formula, but before we do that, we must identify the empirical formula first. So to do empirical formula is very simple, just like you have learned in your school. So to determine the empirical formula, the easiest way is for you to draw the table for each element and determine the ratio corresponding to each of the elements. So from here we have the empirical formula as C9H16O. So the relative mass of C9H16O is about 140. So the mass from the empirical formula multiplied with N, this is what we're going to calculate, equivalent to the relative molecular mass of the whole compound, and we have N equivalent to 2. It means that the ratio is 2, so C9H16O, you multiply everything with 2, so we will have the molecular formula as C18H32O2. And it says here that V contains carboxylic acid and also alkene. And we need to describe a very simple chemical test and also its observation to confirm the carboxylic acid. So the easiest way to determine the presence of carboxylic acid, definitely the reaction with carbonate ion, because carboxylic acid is an acid and carbonate ion is a base. So the simplest carbonate ion compound, that will be sodium carbonate. So sodium carbonate is a solid. When we add to a liquid that contains carboxyl functional group, you will see fizzings or everescence. In the next question, we have a reaction of 3.196 gram of bromine reacting with V. So to be specific, this reaction of bromine will react with the alkene part of V in an electrophilic addition reaction. So generally, each C double bond C will react with bromine to form halogenoalkane, where the bromine will be added across the C double bond C. So to determine how many alkene functional group inside V, we just need to compare the mole of bromine and the mole of V. So first calculate the mole of bromine, and next calculate the mole of V. So if you look at here, there is 0.02 mole of bromine to only 0.01 mole of V. It means that inside V, there must be 2 C double bond C group. In this next question, we have WXY. They all have the same molecular formula, which is C5H10O. So they are added to a different reagent and they have different observation. So let's look into the first reagent, 2,4-DNPH. So to recap, 2,4-DNPH, this is a special reaction used to determine the presence of carbonyl group in aldehyde and also ketone. So since all W, X and Y show a positive result with 2,4-DNPH, it means that all of the compound has carbonyl group in the molecule. The next reagent is alkaline iodine. Reagent alkaline aqueous iodine, it is used to determine the presence of methyl ketone. So since only X produce a positive result, only X has CH3 next to the C double bond O. And the yellow precipitate, this is due to the presence of CHI3. So this is what will be added to this second question. So Fehling reagent is a reagent used to differentiate between aldehyde and ketone. Generally, only aldehyde will produce a positive result in a reaction with Fehling reagent. So since only W produce a positive result, it means that W is an aldehyde and X is a ketone. So in the third question, we need to draw the skeletal formula for two possible structural isomers of W. So we know that W is an aldehyde and it has 5 carbon. So we can start with a straight chain, or we can have a branching. So as you can see here in the second isomer, we have 4 carbon in the main chain and also 1 branching at the third carbon. But you can also have the branching at the second carbon. Or you can have 3 carbon in the main chain and you will have 2 branching. So this type of isomer, we call it as chain isomerism. In this last question, we have a mass spectrum of ketone Z with the formula of C5H10O. So the question already specified that it is a ketone with 5 carbon. It means that Z could be pen-3-on, or it can also be pen-2-on. So from the mass spectrum, we can identify the M peak, which is the molecular ion peak, and this is the M+1 peak. But the question only asks for 2 type of peak, which is the peak at 57 and also the peak at 29. So the peak at 29 is quite straightforward. This is definitely due to C2H5 ion. So it's either this one or this one. So this is the C2H5 ion. And the peak at 57, if your answer is pen-3-on, so this is a fragment corresponding to the peak at 57. So that will be COCH2CH3+. But if you use pen-2-on as your answer, so this will be the fragment corresponding to the peak at 57. So that will be CH3COCH2+. So the identity of Z also depends on the peak at 57, depends on your answer. So if you put the one in brown, it means that this will be pen-2-on. So if your answer is something in pink, it means that it will be pen-3-on.